In the disk drive controller, we've got this cache of requests that have come in to do reading and writing. And they are all referencing different locations on the disk. So let's look in particular about the cylinders. Right? So we've got a bunch of requests that have come in to our disk drive controller. This is a problem that used to be a device driver's domain in the operating system, but now that the disk drive controllers are smarter and have these buffers and so on, it's moved in the disk drive controller. But it's still worth knowing about. So let's say we've got a succession of requests, reads or writes, with these particular track numbers. And let's assume our tracks go from 0 to 100. And we're currently track number 50. The question is, in what order should we execute these? The simplest approach would just be first come, first serve. And the order in which we would do that would be 32, 80, 46, 93, 12, 15, and 18. Okay. It's fair, right? Your request is handled before the previous person's request is handled. But it means we're just shooting all over the place, seeking, 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 seeking. It'd be as if you went to use an elevator and whoever got to the elevator first got to go to their floor. And the next person who got to the elevator got to go to their floor, and so on. You'd just be spending a lot of time in the elevator, right? So a second approach would be what we'll call shortest seek time first. There what we say is, well, what's closest? Let's just do that. So what's closest to 50? 46 is certainly closest to 50, right? Once we've dealt with 46, what's closest? Sure looks like 32 is closest. So we would do 32 next. And then from 32, closest is clearer than 18, 15, and 12. And from there, assuming nothing else is coming along the way, we've got a large jump. We need to go up to 80 and then 93. All right, so this is great, except for the fact that this is not really fair. Right? If we look at our track numbers, which we said are from 0 to 100, the ones in the middle are always closer, have a much higher chance of being closer than the ones on the end. And so you tend to spend most of your time in the middle. And in fact, what can happen if you continually get read and write requests, let's say in this area, you might have a pending request out here that is postponed indefinitely while you're satisfying the closest request, closest request, closest request, closest request. So that's, as we say, not fair. Another approach is what's called the elevator or scan. So the elevator says, we're going to go in one direction, and we're going to start moving in that direction. And until we get to the end, that is the end of the request we have, we're not going to go down. And only when we get to the end of the request will we start going down. But once we start going down, we're going down all the way until we get to the end of the request. And then we'll come back up. So let's look at an example here. We're at 50, and let's say we're going up. In that case, we're going to ignore everything less than 50. And so we would just hit 80 and 93 first. And then we start going back down. And we're going to hit them in reverse order. So we're going to do what? 46, 32, 18, 15, 12. Here's a problem with that. It's still not quite fair to the end guys. Okay? Let's think of why. Let's say we're just going all the way up to 0 and down to 100, back and forth and back and forth. Okay. If we were doing that and we were satisfying requests, these guys in the middle would tend to have to wait less time than the guys on the end. If we look for here at these requests that are happening, in the middle, we just have to wait for up half and down half until we're going to be here again, or down half and up half. But if we're at 100, we're not going to come back to 100 until we've gone down all the way and back all the way. So a modification of this is what's called a circular scan. A circular scan says we only satisfy requests when we're going up. When we're going down, it's an express elevator all the way down. So we will just start going all the way down. And the nice thing about that as well is that's fast, right? If we're going express, we can actually go much quicker than if we're going track by track or 5 tracks at a time or 10 tracks at a time or so on, because we can turn on the acceleration, get going full speed on these heads, and then slow them down and stop at the end. So let's look at what the difference there would be. Same thing, we'd be going up, and we're satisfying requests on the way up. So we'll satisfy 80 and 93. On the way down, we're going to just skip right past 46, skip right past 32, 18, 15, stop ourselves at 12. And then 12, go back up and start satisfying again. 12, 15, 18, 32, and 46. And of course, as we're moving, satisfying requests, new requests may be coming in. And we will be handling those requests just as we do any other requests in here, right? So if we've got a request for 60 that comes in here, as we're going down, we're not going to satisfy it as we pass 60, but as we come back up, then we will go ahead and satisfy 60. So it's a dynamic list of requests that we have.